Let's say you have the letters A, B, C, and D. How many possible ways can you arrange these four letters? So for example, you can have A, B, and then switch these two around, D, C. So this is another arrangement. You could have A, C, B, D. That's another one. Or A, C, D, B. How many possible arrangements are there? Well, the answer turns out to be 4 factorial. And in this video, we're going to try and understand why it's factorial. So if you have E, it's always 5 factorial. If you have n letters, it will be n factorial. We need to understand why it's always factorial. So to understand why, hang on. To understand why, when I teach this, I would ask you to list all the possible ways, and then after a while you're going to struggle and wonder to yourself if you've done like, for example, A, B, B, D, and C. You're going to wonder if you've done this before. As it turns out, you have done this before, but the thing is, when this list gets really long, you can't keep track of everything. You need a systematic way of listing everything, and the trick to understanding why it's always n factorial is to visualize it as a tree diagram. So you've got 4 letters, so you start here. On the first one, you can have A, B, C, D. You see, this is a systematic way of doing it. And then if the first one's A, you can have 3 branches. You can have B, C, D. And then suppose you have B already, then you can have another 2 branches, C, D. And then here you can have D, and here you can have C. And then for this one here, you're going to have 2, 1, 2, this one 2, and so on. For this one here, you're going to have 3, and then here you're going to have another. So for D, it could be A, B, C, and then here you're going to have 2, here you're going to have 2, here you're going to have 2, and so on. So when you draw out the whole tree diagram, you will have a systematic way of listing everything. So for example, this one here is A, B, C, D. So this is the first one. Then the next one would be A, B, D, C. So that would be this one. And then the next one could be A, C, and then B, D. So that's this one, and so on. So when you want to find out all the possible arrangements, it really boils down to you figuring out how many branches there are. And to figure it out, here you've got four letters here, 1, 2, 3, 4, and each one will have 3. So you would get 4 times 3. But then here you're going to have another 2 here. Here you're going to have another 2, so you times 2 and then you times 1. You don't really need this one, but let's put it in there. So that's why it's 4 factorial. If you have another letter, the tree will expand, and then as it turns out, it will be 5 factorial, because if you have E here, this one here, you're going to have another 4 branches. Remember, each one would be 4. That's why it's 5 times 4, and then times 3 times 2 times 1. So it really boils down to 5 factorial. If you have n letters, then it would be n factorial. So every time you do this factorial thing in your mind, so let's go back to 4 letters. The minute you do 4 factorial, picture this whole thing being listed. So you have a systematic way of listing every single possible arrangement. That's why it's 4 factorial. In general, it's n factorial. That's the reason why. Okay.